நீனடை பழகும் மறுவழியே பனிமழையே பருவநிலா தினம் நனையும் முகிலெடுத்து முகம் துடைத்து விடியும் வரை நடைபழகும் வானவீதியே.
Hi, Ani.
Hi, Janakiraman.
How are you?
Doing well. How are you?
Good. So, have you attended a live concert ever?
Yes, many of them in fact.
Many of them? Okay. And so, have you attended a light music concert in particular?
Yes, I have. Yes,
Okay. So, I mean, we just saw one by the legendary S.P. Balasubramaniam. So, how many instrumentalists were there on stage that day?
The one I went to, probably 25 of them.
Wow, 25 of them. So,
Yes.
this must
Various types of instruments.
Okay, so the string instruments, wind instruments, so the flute, guitar, right?
That's
and of
right.
course the percussion.
Percussion.
So
various
you
types of
had
drums.
drum, tabla, and all of that, right? And if
That's
you take a typical song, how many of these instrumentalists do you think would have been taking part in one song?
Yeah, I would imagine several tens of them, right? I would
Yeah.
think.
So about maybe 15 to 20 of
15 to
them would
20
be
of them.
taking part in a single song,
Yes.
right? And we just saw that video here, right, where SPB is singing with full blast, right? He's not trying to control his volume. Neither is the drummer, right? The drummers can never like drum softly, so they just go
That's
all
right.
out on it. The tablis, guitarist, everyone is playing with full enthusiasm and energy, right?
That's
And
right.
I mean, that's why we enjoy that concert so much. But the real question is, when we hear this sound, it doesn't appear that all of them have equal volume.
Equal volumes. That's
right?
right. That's right.
So, I mean, what is your guess? What do you think would be happening behind the scenes for us to hear it so nicely?
See, I have been to some Carnatic music concerts
Okay.
where they spend a lot of time adjusting to make
Okay.
sure. So there is a vocalist, there are some instrumentalists, let's say a violin player,
Yeah.
and there is a mridangam player.
Yes.
And right at the beginning of the concert, and sometimes various points throughout, they make sure to adjust the position of the mic to make sure that the mixing between different sounds happens at the right volume.
Happens at the right volumes, right?
Yes.
So this is not just about position of the mic.
Yes.
So have you noticed this sophisticated instrument in concerts?
I'm sure it must be happening in the background. I have seen this, in a stage setting where it is there in, along with the mic system.
Exactly, right? So this is called an audio mixer, right? And what this system does is to take in all the mic inputs, and the sound engineer who's sitting at this system will tune these knobs, move it up and down, so that the volumes are all adjusted in order to get a good mix in the end.
Yes.
Right?
By the way, I have seen one of these in one of our classrooms.
Yes.
There is a smaller version of this.
Exactly.
Maybe, because there are possibility of various microphones. I have
Exactly.
seen a smaller version of this in our
Exactly.
classrooms.
So even in a classroom it happens, though I think in a classroom the mics are not active at the same time.
That's correct.
Right? Whereas in a concert, all the mics are active at the same time, providing a signal at the same time. So, in fact, this is characterized by the number of channels. It's called a 16-channel mixer, 32-channel mixer, and so on. Right? So, in the concert that you went to, I'm sure they would have had something like a 64-channel mixer, because overall they would have had something like 30-40 mics, right? And just for a tabla or a mridangam, you will have 2 mics. It's not just one,
Yes.
right? So in some sense, this mixer is doing, that mixer does many things. We can't get into all of them right now, but we will slowly, steadily. But for now, it is evident that the mixer is doing some sort of volume control and volume management, right? And the last lecture that we did, we clearly saw that if you spoke loudly,
Yes.
it translates to larger amplitude. And when Boby spoke softly, it translated to lesser amplitude, right? So really the question I have for you is, how do you make a circuit, a rudimentary circuit that does this kind of amplitude adjustment and mixing?
So maybe what you need to do is to, I can imagine you need to change the strength of the voltages.
Okay.
And maybe I'm assuming that because you're doing it electronically, maybe there is changing the strength of the voltages and currents in the
Right.
in some kind of circuit.
Right. But is there a more natural way to add something in a circuit?
I'm sure. See, when I was sitting with Bobby, we learned Kirchhoff's voltage laws and Kirchhoff's current laws.
Yeah.
So the way we learned it was that Kirchhoff's current laws tells us that, you know, if I assume that all currents are flowing into a node, that has to be equal to, so the sum of all currents flowing into a node has to be equal to sum of all currents leaving a node.
Yeah.
So it seems like there is some kind of addition going on already automatically, right? Same way, if I go through a loop, sum of all voltages going through it has to go to 0. So there is some inherent addition and subtraction.
Exactly. So what we'll do now is we'll look at a very simple circuit that uses exactly the concepts you spoke about. Then we'll go to a hardware implementation. We'll look at, you know, various kinds of outputs, and then we'll come back to the theory, right? So I think you're absolutely right. If you basically have some sort of a node here and you have currents I1 and I2, then the current leaving has to be equal to I1 plus I2. This was the KCL that we spoke about. We're going to use this and make a very simple circuit now. Okay, so let's look at this resistor R1. Okay, this is any arbitrary voltage source. For now, we can assume it's a DC value, let's say 1 volt for now. Okay, actually it's going to be a time varying source. Okay, then you have another resistor R2, another time varying source V2. Okay, and I'm going to develop some voltage here. Okay, and I'm going to call this node voltage as Vx.
Okay. Okay.
So intuitively, you know, what you said is exactly happening. So there is going to be some current in this arm, which is I1, which is capturing the information of V1. So assume that V1 is the mic output from one of the mics. V2 is the mic output from another mic. Okay, this is going to translate to some sort of current I1 and I2. This has to flow through this, right? I and I has to be equal to I1 plus I2 by KCL.
Okay.
And the voltage Vx has to be I into R.
I into R. Yes.
Right? So if you have a circuit like this, technically it should be possible to do some addition. So what we will do now is to switch to the hardware side, right? And we will look at this circuit here, right? So what you see, let me also switch to this. Okay, so what you see on this is, as usual, a breadboard, okay, on which we have built exactly this circuit.
Okay.
There's a voltage source, okay,
Okay.
and this voltage source V1 is coming from the signal generator on the kit.
On the kit.
Okay. And V2 is the signal generator 2 from the kit. You know, there are 2 ports where you can generate 2 different signals, right? So that is what is happening here. And we are now going to look at the working of this experiment in hardware.
Perfect.
Right? So also what we have done is this blue component here is called a potentiometer, and that's essentially a variable resistor. So if you turn that screw,
yes, I see the small screw here.
Right? You can adjust the resistor so that you get a variable resistance there, right?
Okay. I think you showed that the voltage was I times R. So now I can get any, you know, by changing the value of R, I can get larger Vx or smaller Vx.
Correct. So, but what we have done here is the potentiometer is not in this one.
Okay.
It's on this one. So that we can,
yeah.
Okay. So this is a pot.
Yes, makes sense, because if you just make R variable, I1 and I2 will get scaled by the same amount. We do not want to do that.
We don't want
to scale one with respect to the other.
Exactly. Right.
Makes
so
sense.
therefore, we are going to do it that way.
Okay.
And let's see what happens. So for now, we have set the resistor R1 to be 400 ohms.
400 ohms.
Resistor R2 is also approximately, I think, 390 ohms or 400 ohms there.
Okay.
And the resistor R is 1 kilo ohm, right? Let's just write that down. 1 kilo ohm, that is 1000 ohms. Okay, R1 equal to 400 ohms and R2 equal to, I think, 390 ohms.
390 ohms.
Okay. Right. So
Right.
what we are going to do now is we are going to go and set this voltage here, right? So we'll jump to this wave gen window, and what you see is we have DC, okay, on channel 2 with a amplitude of 2 volts. It's
2
a
volts,
DC
okay.
source of 2 volts.
Okay.
Channel 1 is DC of 1 volt.
1 volt.
Okay? And this we are going to now enable, and we'll go and observe. So what we have done now is this Vx is what we have probed. We are sending this to the oscilloscope
Okay.
window of this kit.
Of the kit. Okay.
Right? Very similar to the mic experiment we did earlier, right? Except that now we have 2 sources additionally driving this, right? So what you see is, maybe I will stop this, and let me stop this as well. Let me stop this as well, and then you run. Okay, I'm going to run this. So both are running now.
Okay.
And you get a voltage of approximately 1. How much is it? 1.25
something
volts.
like that. Yeah, 1.25.
Right? 1.25 volts.
Okay.
So we are getting Vx equal to 1.25 volts.
Okay, excellent. Okay.
Okay. Now, do you want to try and tune that pot?
Sure.
Right?
Sure.
So let me give you a screwdriver.
Okay.
Okay.
So let me try tuning this pot. Is it? Do you see something changing?
I see something happening.
Okay. So let's see if.
Yes, I
Is
can
it
see the
moving?
line moving up.
Okay. Excellent.
Right?
Yeah.
So,
So the potentiometer is working.
yes.
So the addition is also. Oh yeah, I can see it moving
Right.
much. So as I'm rotating it faster, of course,
Yeah.
it's changing by
Right.
quite a bit.
It's going
excellent.
up.
Excellent.
So okay.
And of course,
And
so let me bring it back to its original value.
Yes.
You wanted 1.25, right?
1.25.
So I'll bring it back to 1.25. Let me know when to stop. I think it's now at 1.25. Very
Down,
close to
down,
it.
down, down,
Little bit
down,
more?
down. Stop.
Ah, okay.
Okay.
Excellent. I set
Right.
it back.
So clearly, what we have seen is, in a simple DC case,
yes.
you are able to control the voltage output as a sum of these two. We'll see exactly what the coefficients are and all that stuff in some time.
Okay.
But now it gets more interesting, because you know the mic output is not going to be a DC. It is a time varying output. We already saw that. So let's now give something more interesting.
Ah, okay.
Okay, I'm going to give a sine wave of 10 kilohertz. Okay, I'm on both arms. I've given a sine wave of 10 kilohertz, and I'll give an offset of 0.
Okay.
Okay, maybe I'll just make this 0. Okay, so that there is no, I mean, that offset was given this because we wanted a DC
voltage.
right?
Yes. And what is the amplitude of the sinusoid?
It's a 1 volt.
It's a,
both
of them are 1 volt.
Exactly 1 volt.
Okay.
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 And let's go and see what happens here.
Okay.
Right. So you see that, you know, maybe I'll stop this for a moment so that it gets captured a little bit. You can see that, you know, it's a 1 kilohertz. In fact, I can change this frequency for you.
Yes.
I can make this 1 kilohertz, right? And I can make this also, sorry, 1 kilohertz. I'll go here and I'll say run. Right?
Ah, okay.
You see that.
Maybe. Oh, perfect. So the frequency has changed.
Frequency has changed.
Okay.
Right?
But the amplitude has stayed the same.
Amplitude has
because
stayed.
you have changed only the frequency, and not the amplitude.
And not the amplitude, right?
Perfect.
And now if you go ahead and start tuning this thing, and you can try it now. Maybe I'll let it run. You can again tune the potentiometer and see what happens.
Okay. Oops. Do you see it moving? Amplitude?
Yeah, it's happening. You just need to continue.
Yes, perfect. I can see
Right?
it moving.
You can see
I
it,
can see it
right?
changing.
You can see it shrinking
Yes,
and
of course.
this thing, right?
Of course. Perfect.
But in a real concert, you know that the vocalist frequency and the guitar frequency are going to be vastly different.
Yes.
And what you actually need is not just an addition of two similar frequencies, but two completely different frequencies. So I'm going to add one sine wave of 1 kilohertz,
Okay.
another sine wave of 10 kilohertz.
10 kilohertz.
Okay.
So the result will not just be a simple sinusoid like what you got last time.
It cannot be, right? So this, if you look at sine A plus sine B,
Yeah.
it's a product of sine A plus B by 2, sine, cos A,
Correct.
something like that. So
Okay.
you will get a very interesting output.
Okay.
And this, if you look at it, it is a product of some smaller frequency, because you can see, I'll stop it and show you. You can see there is a small 1 kilohertz type of slow
Yes,
wave.
I can see that the overall outline of this curve looks like a 1 kilohertz curve.
Exactly.
But inside I see a lot of 10 kilohertz terms.
Yes, and
Right?
why is that?
Interesting.
Because sine 1 kilohertz plus sine 10 kilohertz is sine A, there's an A plus B term by 2
Yes.
and A minus B term by 2, which is
Correct.
a product, and that's
Perfect.
what you see. In fact, this is what we call amplitude modulation that we will see later
right.
in communication.
Perfect.
Right? So clearly the addition simply works from this kind of a circuit.
Perfect.
Right?
By the way, I wanted to ask you. So suppose I gave one as a DC and not just a sinusoid.
Yes.
I wonder what would happen.
Good. I think we can go ahead and try that. Right? You want to make this a DC with an offset of how much?
Maybe 1 volt?
1 volt again?
Yes.
Okay.
So what I then expect the
Yeah.
output to be,
Yeah.
it should be a sine plus DC,
Exactly.
right?
Yes.
So it will be some DC plus some, so it will be like, let's say some constant value plus some sine.
Yeah. So the sine
Okay.
wave should have just elevated
just move
itself,
up, right? Okay.
So let's try that and see.
See if that works.
See?
Yes. Oh wow.
The sine
Amazing.
wave was not now centered at 0.
Perfect.
It has gone up. In fact, you're right. If I make this 2 volts, you'll
Perfect.
see it
It's moving
further
up even further.
go up.
Nice. So I can, so what you're saying is I can actually add a DC and a sinusoid and shift the sinusoid up and down
Exactly.
to whatever I want.
Exactly.
Okay.
Absolutely.
Sounds like an interesting property also.
Yes, indeed. Right?